Hi, grade 10s. Welcome to the first summer school session. The focus is on electricity, and this video is to help guide you through working through the PhET simulation. In this session, you're going to be investigating conductors and resistors in series and parallel. So type in the PhET circuit construction kit on Google and click on the link and wait for it to load. It will take you to a screen that looks like this, and it will take a few seconds to load. So just be patient and wait for it to load. Click on the intro icon and it will take you to the introduction. First, start by making sure things like the show current button is clicked by looking at the electrons. Make sure you include the labels and the values so that you can see the readings. There will be a voltmeter for you to read the voltage across the different parts, and the ammeter to measure the current in the circuit. And on the left-hand side, you will see the components of the circuit. So there is a battery. You can put one or two batteries in. Make sure that where those circles are, that is where the components connect. That is the wire. Those blue little dots with the minus showing the electrons that are already in the wire. So build up your circuit. As I'm doing here, you can move the pieces along, you can stretch them. And as you build your circuit, you're getting ready for the investigation. Make sure to include a switch that you can switch on or off and put the switch in the circuit. So I would suggest that you start off by building up your circuit as I've shown here. Just leave a gap to put in the different components that you're going to be investigating, as I have done here. And you have to make sure that where the red circles are, that those parts connect so that your circuit is a complete closed loop. Now, you are first going to investigate which substances are conductors and which substances are insulators. So you'll use things like the eraser, the pencil, the wire, the paper clip, and so on. So you will put it in the gap and make sure the switch is closed, and then switch the close the switch. You can measure the voltage across the batteries. Now, as you can see in this animation, with the electron flow, it's indicating a fire. So there's a short circuit, but you can see what the current is. If you want to cut the eraser out of the circuit, it's a lot easier. You go to the end there. I've opened the switch there, but go to the part that you want out of the circuit, and you can see once the switch is closed, there is zero current flowing, but there is voltage across the batteries. Now you can cut out the eraser using the scissors icon, and you can then put the next object in, such as the pencil, and so see which of the substances that are here, such as the paper dollar bill, the paper clip, and the coin, are conductors or insulators. You have to make sure that the connection is closed. There you can read the voltage once the switch is closed, what is the current, and that will help tell you whether the substance conducts electricity or not. Just two more important things that I need to tell you. You must make sure that the voltmeter is connected across the components, and the ammeter must be in the circuit. So make sure that little cross mark there is in the circuit. So voltmeter must be across components. The current must be, to measure the current, it must be in the circuit component, because remember, current is a flow of charge, so it's the flow of charge through the components, and the voltage is the potential difference across 2 points in the circuit. So just remember the placement of the ammeter and the voltmeter when you do your investigation. So grade 10s, the point is put in the different components that are there, such as the coin, the wire, the pencil, the dollar bill, to see which substances are conductors and which are insulators. If they are conductors, they will not conduct electricity, so the current, they will conduct electricity. If they are insulators, they will not conduct electricity, and the current should read 0. So if you have any questions, please ask either myself or the tutors, but the point is, use the PhET simulation and have fun. Now, for the second part of this PhET simulation investigation, you're going to be looking at light bulbs in series and parallel. You need to make sure that you connect the light bulb at the bottom and over there to ensure that there is a flow of current. As you can see, I haven't done that, so all I have is a circuit without a resistor, which causes a short circuit. So you can see they are not connected there. You have to make sure that the light bulb is connected in those two places. So it must be connected there, and the wire needs to be connected there. So they must be connected at the 2 points in the light bulb. As you can see, I also played around a little bit, and you can do the same, but you will see there must be a connection at the 2 points on the light bulb. So now, as I'm showing you there's the first connection, and now I'm making the second connection at that top point there. And once I've closed the circuit, because remember you need a complete loop, there you will see the light bulb will light up, and you can measure the voltage across the batteries and the current in the circuit. And then you can add another light bulb in series, a third light bulb in series, maybe even 4 light bulbs in series, to see what happens to the current in the circuit and measure the potential difference across each light bulb that you add and see what happens to the potential difference. So there again, you can see how I've completed the circuit. Is that a series circuit? Yes, there's only one path for the electrons to follow. And there I'm showing you how you can measure the voltage across each light bulb. So now here there are 2 light bulbs in series. Now let's see how you can set up a parallel connection. Remember, a parallel connection must have a break in the circuit where the current will have 2 paths to follow. So those are resistors in series. Now, how can I change that to a resistor in parallel? And again, just to remind you, remember to always remember to take voltage readings across the components. And that is what you will be doing for the rest of this session. So let's now have a look how we can set up a parallel circuit. Just a reminder, if you look here, you can see there's only one path, a single path that the electrons are following. This is why this is a series connection. So let's now set this up so that this is a parallel connection. There are my 2 light bulbs. You can move them around. Remember, this circuit will not look exactly like a circuit diagram because this is simulating actual components and where you would have to put the wires and so on. But you can double check that it's a parallel connection if there are 2 paths or 3 paths or 4 paths for this circuit to follow. So there I'm completing the circuit. Remember, once again, the light bulb must be connected at the bottom and the top. So there's a single light bulb. Okay, I'm opening the switch. Now I'm going to add the second light bulb, but this time in parallel. So there you can see I'm connecting it to the bottom of the light bulb, and I'm connecting it here. You can see it's not connecting there, connected to where the dotted line is. You can see I have not completed the circuit there. That is why the light bulbs don't light up here when I close the light switch. So you've got to make sure your connections are creating a closed loop. See, only the one light bulb lights up because that second one is not connected. And when I've connected it to that end, you can see both lights will light up. You can read the voltage, read the current. So move that almost like that eyepiece that measures the current, that's looking at the electrons at any part in the circuit, and it will give you the current reading. Okay, great, 10. So now you can play with the simulation. You're going to set up a series circuit with first build a single circuit with one light bulb, then build up a series circuit with 2, 3, and 4 light bulbs, and then take both voltmeter and ammeter readings across each light bulb and at different points in the circuit, and then you will build up a series circuit and do the same thing. What is the voltmeter reading across each light bulb, across the branch? What is the current reading in each of the branches in the entire circuit? And please record these values on a sheet of paper. So you will need to construct a table with how many light bulbs there are, whether it's a series or parallel circuit, voltmeter readings across each light bulb, across the battery, and also the current at various points. So it would also be a good idea for you to draw a circuit diagram for each circuit that you set up next to your table. So the idea is play with the simulation, get readings, investigate, see what happens, and I and the tutors will be here to answer any questions you might have. So I hope that you enjoy this lesson.